We have Professor Sanjay Mahajani. He is going to talk about very important things, and some of the things I have not covered. He is going to talk about it. I'm going to invite Professor Sanjay Mahajani.
So I think the overall structure of this course, what exactly you're supposed to do and everything is very well explained by Professor Kannan. I'll just take 10-15 minutes. By now you realize no, that it's a very easy course, right? Straightforward. Why are you laughing? See, one project, 6 students, huh? So much. So, and we have so many faculty members supporting you, we are getting external experts and all. So you should do a good job. So what was given there, no, it's the minimum that you are expecting, okay? And we are expecting you to do something more than that, then only you'll get A square, okay? All right. So as Professor Kannan said, like it's a culmination course, right? That means whatever you have learned so far, you are going to actually apply not in a physical sense, but at least on the paper, okay? So whatever you have learned, okay, in your core courses like heat mass transfer, reaction engineering, process control, everything, you will be actually applying it for a particular problem, okay, a design project, right? So it's a good chance if you miss anything earlier, probably the last chance to learn again, okay? And as Professor Kannan said, you may start liking chemical engineering after this, okay? Probably it's too late, but still not bad, okay? So what I'm going to tell you, of course, the importance of this course is something that is, like already said, it's related to what you learned, but I'm going to tell you from the point of view of somebody working in industry, okay? Now, how this particular project will be useful there, okay? And whether we do something similar in industry, right? So when you say about chemical projects, now we're talking about a production of a particular chemical for certain capacity, right? And so there are many chemical plants, okay? And many chemicals being produced, right? And most of the times, no, investments done are very, very huge, right? Not in order of lakhs, not even few crores, right? Most of the times of the order of say, what, 25 crores onwards, all the way up to 10,000. 10,000 is too large for a mega project like refinery and all, but for a chemical project can be as high as 3,000, 4,000 crores, okay? So it's a huge amount that somebody is investing. And what's the basis for that? The basis is this, right? Basis is this report, okay? So you understand the importance of this, right? So generally the chemical projects, they are implemented. Now, who will like to produce chemicals? So there are 3 entities, I keep telling this, okay? A manufacturer, right? So a manufacturer, any example? I know what you're going to say. Somebody said it already. Producer, I want to produce a chemical. Any producer, you know? Reliance, yeah, right? A chemical producer, say Reliance, right? A petrochemical company, right? So would Reliance have a technology with it? It won't have, right? So there is a technology licensor, right? So there is this licensor. Sorry, it's probably a repetition for some of you, but it's a class 4th year and 3rd year combination. And its repetition is all right, okay? Anyway, there are many things you're going to get repeated in a design project, okay? So this is again a revision of what we have done. So license, the technology that you're going to use and implement it. Is that all? These 2 entities can implement a chemical project? You need EPC company, right? You need EPC company. So these are the 3 main players. They will interact with each other and do a chemical project. So when I say chemical project, like it is when you have some idea and you actually build a plant and start commissioning it. So this is a period. It can be 1 year, it can be 2 years, it can be 3 years also. But beyond 3 years, not desirable, right? So in this particular period, you do many activities, okay? It's like plane taking off, no? And then once you go at a particular height, you achieve steady state, start manufacturing, start minting money, right? But till then, whatever you do is very, very crucial, right? And the design project or preparing the design report is a very important part of it, right? So, so it all starts with that. So what are the activities in project management? Some of them we revised yesterday in the project management course also. You start with ideation, right? Start with a concept that I as a manufacturer, I may think I want to produce styrene, okay, right? I don't have styrene plant myself in my manufacturing complex, okay? There is no styrene producer in India, right? Worth making styrene. There's a possibility of making money out of it. This is one idea. This is where the project starts, okay, right? And I means whom? The producer, right? Of course, there's a team, right? There's a business development team in Reliance, okay, which may think about it, right? So once that idea is generated, right? So that's the first step. That's the first step, right? Conception, right? And once that idea is generated, what do you need to look for? Huh? What next? Market. Very good. What next? Huh? Done. Good. So there are three things that you need to do first, okay? That whether there is a market for the chemical that I'm producing or I'm thinking of producing, right? And third and very important thing is the technology. And this is, see, the project that you're going to do, you're going to follow these steps, okay? Right? For you, the ideation has already been done, right? You already given your chemical, okay? You're lucky. Huh? You don't need to ideate, right? But it's better you see whether a chemical given by us worth producing or not, okay? Is there a market or not, right? Is there technology, good technology or not? Now, what's the meaning of good technology? Cost effective, and as Professor Kannan said, and probably Yogendra will repeat or rather emphasize it, that whether it's environment friendly or not, right? All these things you are going to see, right? And of course, the market, and Professor Rahul will tell you how to search for market, whether like chemicals, whether we are importing it or not, okay? Or there's surplus production happening in India. Certain chemicals are producing at a very large scale, okay, and we're exporting it, right? So these are three important steps. And again, just before first stage evaluation, you'll be doing all these things, right? And what comes later, no, is a preliminary feasibility report that you prepare, okay? So start doing some economic calculations, okay, because you have some technology available, right? Start writing down numbers and so on. And there is something that you've done as a part of economics course, right? Calculate the production cost, revenue, right? Profit and so on. Now, I've been working with numbers. No? You may get some attractive figure at the end of the day that your payback period is of the order of few minutes, right? Possible, okay? But then you have to go back and check whether the calculations are correct or not. And that's why you need to do detailed calculations, right? And now what follows is very important. And now you have to look at the technologies, you have to take a deep dive into it, right? Understand the technologies very well. Now producing phenol, you can make it from benzene, you can make it from toluene, you can make it from chlorobenzene. There's so many possible routes, right? You have to identify a particular route, right? And see whether which one of them is good or not. And Professor Kannan said the selection, okay, the process selection, the route selection is an important part. You may do some preliminary calculations for all the routes and finally say that fine, this is the best one. Okay, there is no hurry. No need to really rush and take a decision and start doing simulations. Don't do that. Be realistic. Okay. See, I have seen most of the times now, students give so much importance, they give so much importance to simulations that if the simulations are working well, if you're getting some numbers, you think that your project is over. That's not the case, okay? At the end of it, what is important is that you're going to tell us the economic feasibility and now, of course, the environment feasibility also of the project that you're going to do, right? So only simulations is only a tool, take it, okay? Of course, you should do it, you should master that tool, but at the same time, make sure that that's not the end of it, okay? Right? So, you may do some preliminary calculations, the design course you've learned already, how to do linear balances, come up with the quick estimates and so on, right? If required, you can do it for multiple routes and select one of them. We'll appreciate that, okay? Right? Site selection, it comes much later, but yeah, by now you know what raw materials you're using, okay? Whether you have surplus raw material, benzene is surplus in India. Can we make something out of benzene? So, or rather, if my raw material is benzene, can I put a plant in India? Oh, you have a choice, you can put a plant in Sri Lanka, Bangladesh, wherever, right? So, site selection is also very crucial because your economics depends on that, right? Your market depends on that. And this is where now detailed economics comes in picture. And while doing this, your project will come handy. When I say detailed economics means what? Now, of course, economics is very easy, like, okay, just few formulae that you have to deal with, okay? But it's very important how we deal with them, right? So, on one side, your project cost, on the other side, your production cost, right? Project cost would include equipment, it would include instrumentation, it would include electrical part of it, and there are additional costs also, overheads and other things, right? So, that is project cost. Now, how will you calculate this? Now, as Professor Kannan said, there might be some data available in literature. Somebody has done it in US, okay, in what, 2000, right? And the cost was so much, right? And I apply some factors and try and get this. This is one way to do it, and that's, I would say, a preliminary calculation. But then, if you want to get an exact estimate, you have to do design, right? You have to actually work out the dimensions of the reactor, distillation column, pumps, compressors, everything. And then get the cost for each and every item and see whether your cost that you earlier predicted is somehow close to what you're determining, okay? By actually doing the calculation. That's what detailed cost estimation is. And in a design project, you're supposed to do that. We'll appreciate it more as much depth you go in and as much breadth also you cover, okay? Because this is an open-ended project. Of course, we have given you well structured program, you can even go faster, okay? There's no harm in it, right? You can do something more than what we have told you, right? So as Professor Kannan said, like, if we are asking you to do a detailed design on one piece of equipment, why not all, okay? It's possible, okay? Right? So this is what is done, and after this, your report is ready, okay? And this is where, like, this. So by the way, I didn't tell you the roles of this, okay? So now, this is a licensing company which will give the license to the manufacturer. By the way, manufacturer and EPC together would decide, okay, whether this license is good for me or not, okay? So I have to do some calculations like what you're going to do in a design project, right? And then if I find this promising, I will have several meetings with licensor. If I find this promising, then I decide to go ahead, okay, and actually buy the license, right? So that's the procedure. So all these calculations that you're going to do in a design project, who does those calculations? The licensor does those calculations? No. Then, who does those calculations? Huh? The producer would do those calculations? Huh? Usko उठाओ ना. Who does those calculations? Producer? नहीं, अरे not a single person, come on यार, क्या चल रहा है? हाँ? कौन करता है calculations? Guess तो करो यार. हाँ? You didn't get a question? Huh? This is a detailed economic feasibility report. Who does this? EPC company, no, so straightforward. Huh? So, not necessarily the EPC company would do it, okay? At same time, if you are a manufacturer, if he or other manufacturer has to actually deal with the EPC company, then on one side, a manufacturer will also have a team working on it simultaneously, right? Okay, and both of them would do this exercise if the project is very large, right? For smaller projects, and if there are limitations at the producer side, entire contract is given to EPC to do those calculations. Try and understand design project, okay? How it is implemented, who does this in industry, right? And as I said, like while doing the design project, feel like you're in the industry, okay? Because most of the courses, and there's understanding of theoretical concept, but now you're applying them as if you're working in industry, okay? Right? And after this, now you're taken a decision whether to go or no go, right? Then you have to do all these things at a ground level, okay? Now, this is part of the project which is not really part of our design project. This is something when you're actually going from concept to commissioning, right? So, whatever is there in the red, okay, is something that is supposed to do as a part of design project. So, this is the context I wanted to give it to you, okay. Now, coming back to doing this project, then most of the things I already told you, but again, I expect that not just do the things that are told to you and think that you've done a great job, okay. Every project is open-ended project. There is so much depth into it. There is so much breadth, okay. So, you have to cover that, and there's a lot of expectations. As I said before, we are providing all the support to you. And of course, economics and there's a possibility that you may need to make many assumptions, right? And but then again, assumptions also you have to do them sensibly, in the sense that you apply some understanding, theoretical concepts, right? You can't just say, I don't have kinetics available, I assume volume to be 1 meter cube and go ahead, okay? Can't do that, right? Okay, so somehow you have to come up with something similar, some other reaction that's happening, similar catalyst or so on. That's about kinetics. Vapor liquid equilibrium is also same, a compound which is not listed in library. There are ways to do that, like you can use unifac, uniquac and so on, right? So how to do assumptions is also very important, you will learn in this particular course. So overall, I'll repeat what Professor Kannan said, it's a very exciting course, and do maximum, okay, so that you become a complete chemical engineer, because unless you do a design project, you are not a chemical engineer, okay, right? Whether you want it or you don't want it. Okay? All right, so all the fielding is set for you, okay, and you have to just do, you have to bowl at a right spot, that's it. Okay. Thanks.